How's that for brutal? Carrier package unit. We got condenser fans. Unofficially, we have a blower fan. I can feel it. But we got no compressors. This one is warm. This one is warm. Neither one are hot. All of our stages are calling. It's game time. See why we're off. I mean, we've got to be off on thermal. If we were off on high pressure or low pressure, the contactors wouldn't be pulled in. So a little bit alarming. Sit tight. My initial assessment by the fuel was incorrect. We do not have a blower motor. So no blower motor, no compressors. This is high voltage, but there's a capacitor, so that's not three-phase. All my three-phase units are shut down. Look at my drive. Looks like I got a fault light on that. If I rebooted the unit. So we're gonna go back and check our three-phase coming in. All right. Now. 1 to 3. 120. 2 to 3. 120. 1 to 2. 208. Funny business. I wanted to wait before I powered it down because, okay, so our line is coming in at the top. We got three-phase coming in. 1 to 2. 2 to 3. 1 to 3. Come on, doofus hands. All right, long story. 212, we got there. Let's check our line 3 again. Line 3 again. I got something for you today. Yes, sir. I got the Mega Homer. So we've lost the fuse. Unbelievable. Deja vu, right? So the other thing I don't see that's deja vu is line 3 was really burning, and it's discolored, but it's not crazy. So let me grab the extra fuses. I left them in the unit right behind me. So we're gonna grab the FLIR, we're gonna grab the Megger, and give it a go. Okay, so I checked everything to ground on this unit. I checked the north side, south side. I put my terminal in ground, and then I went peg by peg while I was holding the contacts in, so that there's nothing short to ground that should explode when I fire this thing up. So that being said, I also don't see any burn marks or anything jumping out at me like that other unit. So why did it blow its fuse? Oi. Here we go. 3, 2, 1, don't blow up. All right. So thermostat's got to wake up downstairs. It'll activate our lovely variable speed blower motor. And then it'll be on a lockout. So in a minute or two, the compressor will kick on. I'm actually gonna put my leads back on. I just wanted to see what we were pulling. So if I fired it up, all of a sudden we were getting crazy amperage. Let us re-verify. 1 to 2, 2 to 3, 1 to 3. All right. I want that back on there because I want to watch amperage as the compressors come on. I could jump it out if I have to. Let's put this on all the way so we don't stress that. Now, when I got here, they were warm but not running. And the units were pulled in. So I believe that the thermostat will call and pull them in. I hate to make you sit and wait here, but I'd hate for you to miss something exciting. So I just jumped out Y1. And what I mean by that, right, is I just bypassed the thermostat. So R is sending my 24 volts down. My thermostat sends it back up to Y1. So I just jumped it so I could force the unit on. So I could see first stage. So here's first stage, it's pulled in. Condenser fans are running. I know the frame rate is funny. Like, I swear to you, it's spinning this way, very faster than you can see. So we're gonna let that run. And we're pulling 17 amps. LRA is 11, no, clock rotor amps is 110. Operating is 19. And this isn't just the compressor either. So we'll tap on here, hang on. And it helps if I hook up to the right compressor. But 17 and this one's allowed to pull 20. Tell you what though, man, it's real hot. I got good temperature coming back. I'm gonna put gauges on this after the dust settles just to make sure she's not running a little short. But I don't feel like from the return line that it is. So let's see when we engage both. Second stage. This is a 60 amp fuse. It's on a 50 amp breaker downstairs. I see no reason why this should have shut down. So I'm actually going to jump out. I'm going to pull this off and probably it's calling now. Right, so now it's calling for Y1. Oh, look at that. I'm going to catch 24 volts when I touch that. So now if we put this on Y2, let's kill this thing. Let's do this backwards. So what I want to do is I want to jump out Y2 so that we get both. Yeah, no need. System just pulled on, second stage. That's what I wanted to see. We're gonna let this run. I'm gonna get the FLIR and I'm gonna look at the heat signature on everything electronic, see if we got a loose connection somewhere. And then after that, we'll open up the mega ohm, test components. So we've been running for a while at 32 amps. Don't love those. Deja vu, man. This is exactly what happened on that giant unit over there. But again, the difference is, yeah, there's a heat signature on the blade, right? So this is looking at that blade is definitely warm in relation to not the center one, but the left one, which, I mean, they're all pulling 31 amps. So I wonder if I can put some dielectric grease on there. I can pop it open and then put some dielectric grease to help it make a better connection. That's not screaming to me. The fuse isn't overheating. And the north end of the fuse is definitely hotter. Yeah. That's why I love this thing. Also, right, so running through here, I know it's bright. So other than my relays, which that's okay, looking at the actual, there's nothing alarming here. From a wiring perspective, that's my relay, that's fine. We need to get rid of these fuse disconnects and just put in a non-fused. Be done with this nonsense. All right, so I want to. This is my my mega ohm meter. So I like to put it on the shaft of the motor, and so what we're going to do with this is we're going to send DC voltage through the windings, okay, and see how insulated it is. So it should be more than 4,000 mega ohms. So at 250 volts, I'm going to hold test. You can see we're putting 267 volts DC, 4,000 mega ohms. So winding's good. Let's try 500. Right, the more volts we send through, it's going to want to arc if there's any shortnesses at all. See, look, there's a little bit, but then at the end of the day, good. 1,000 volts. 1,000 volts, still 4,000 mega ohms. The windings in this are absolutely good. So also, just a point of information, this has this VFD, so I couldn't have gone back and measured it in there. I'd have been measuring windings in the VFD also, would have been weird. Plus the VFD circuit is open, so I wouldn't have been measuring that at all. So had to check it here. Let's check the compressors. All right, so I'm powered down. First thing I want to do, I scraped me a clean spot on there, and I'm going to set this to continuity and make sure. So confirmed, we have a good continuity spot. So terminal by terminal here. Let's grab this guy. Set her for 500. Hit it. Don't love that. Bet if I put that to 1,000 volts, 550 mega ohms, 600. Realistically, this thing's running. Sorry. 250 volts. So 267 volts. $17.60, $17.80. So that's not encouraging. Let's try a different circuit and see if it's any different. Nope. So what do you make of that? What's the minimum acceptable resistance for the windings? Over 4,000 is, according to the manual of this, if I understood it right, over 4,000 is basically a non-reading. So does that mean 2,000 is okay? Help a brother out. At 1,000 volts, this thing is struggling. At 250. Wow. So at 250, no problem. At 500. So at 266 volts, the insulation is beautiful. If I up that to 500 volts, the internal windings of that compressor show that they're compromised a little bit because my resistance is not where it should be. This is early stage compressor failure. Question mark? At 250, second stage is spot on. And let it discharge. I'm gonna move this back to first stage again. Set it for continuity. Beep, we're good. Take this off at 250. At 250. First stage struggles. Guess which is going to be the first compressor to go, folks. First stage. I want to note that I'm protected by a 50 amp breaker. Here's why that's important. Do you see it? You see what I've done? Line 3's line side is where the disconnect is bad, where it's overheating. You can see that unit behind me. We had this exact situation. We did this, the unit started single phasing after it blew out that fuse again, and it burnt up like a $700 motor. So, I just showed, I've got my protection downstairs. If this was a non-fused disconnect, which is what I'm gonna replace it with anyway in 2 days, this is exactly what it would be when the breaker is on. So those are wired together, nice and tight, good connection, so that my line 3 is not gonna blow the fuse. If I have an actual mechanical problem, it's gonna trip my breaker downstairs. No harm, no foul. But I'm not gonna single phase. Here we go. Also, probably something you guys are already yelling if you know, because I'm new to the mega ohm game. I was just reading some manufacturer's material, and it was saying to be cautious with the mega ohm. Be cautious with the mega ohms on compressors, because with the oil in the compressors, you can get false outs. So like how I was showing at 250 volts, I was showing a lot of jumping around on first stage. They're saying that can easily present false because of the oil. So it's really meant for motors more so than compressors. But all right, I'm gonna wait for first stage and second stage to kick on for this unit to start cooling. I'm also gonna look at a slush machine while I'm here. So next time you see this guy, we'll be replacing that disconnect with a fuseless.